Hello guys, welcome to MoBileMaThS with Kamtrai. Today we want to look at partial variation. So I'll introduce, let's say for example, we are in a hotel business. We have got a hotel and we're running a business. So in a hotel business, we can incur some costs on wages, fuel, food that is being fed to the people that visit the hotel. So let's look at, for example, the overheads of wages and fuel. These can be constant, they can remain the same in a stable economy. Then the food cost, now it depends on the number of people that we are feeding, the number of people that come on our hotel to visit. So this will be depending on the number of people that visit our hotel. So at the end of the day, the cost of the overheads generally remain constant, but the cost of the food will be proportional to the number of people being fed, and hence we can write this and have a partly constant and a partly variable variation, whereby in algebraic terms I can have C is equal to A as the overheads plus K as the food cost, depending on the number of people. That is the partly variation that we can have for a hotel, for example. Let's look at some worked example that we can have. Okay, so here I've got a C is partly constant and partly varies. So whenever you have something like partly constant and partly varies with, automatically you should think of something that of the hotel example that I just gave you. So we can even write this one as C. We can write this as C is equal to A plus K N. Okay, then we are given that so they give you two different values. Like in this case, we are given that C is equal to 45 when N is that. Then they also give us another value, C is equal to that when our N is this. So with those two different variables, you automatically form two simultaneous equations. You form two simultaneous equations. Then with those two simultaneous equations, your task will be to find the two unknown variables, the A and the K. Those will be the constant values that we have. So those, after finding them, then you can find the formula that is connecting C and N. Let's do that. Okay, so I've got my C is equals to that. So the values that we are given are, we've got 45 is equal to A plus K and a 10 there. Then the second one, I've got 87 is equal to A plus K and 24 there. So this is equation number 1 and equation number 2 here. So what I can do is I can subtract equation 1 from 2. Okay, or vice versa, I can say 2 minus 1. Okay, so if I say 2 minus 1, it means I'm simply subtracting these two, subtracting 1. So if I do that, 87 minus 45, I'll get 42. A minus A, I'll get 0, plus 24 minus 10, I'll get 12 there. So this is K, sorry. I'll get 12K there. So I can divide by 12 by 12. Then I get my value of my K. So 12 into 42, I'll get 3. So my K value is equal to 33. It's equal to 3. K is equals to 3. Now that I have got my K, I can use any equation to find the value of A. So let's use the first equation. 45 is equal to A plus K N. That one, let's use that one. So now I've got a 3 there. Okay, my N here is 10 there. Sorry, my A there is 10. Let me write 10 here. let me write 10. Okay, like this. Now substituting, I've got 45. I have got 45. Remember, my k is 3, so I've got 45 is equals to a plus 3 by 10. I've got 45 is equal to a plus 30. Then my a becomes, I can simply subtract 45 minus 30. Then I get my a is 15. Okay, now I've got the two unknowns. I can now write my relationship. The relationship now becomes, it was c is equals to a plus kn. Now it becomes c is equal to 15 plus 3n. So this is the relationship that we have. With this relationship, we can find the unknown. So the second part of the question was asking us to find c when n is 18. Let's find c when n is 18. Okay. C when n is 18. So we simply substitute our n with 18. So it becomes c is equal to 15 plus 3 by 18. So we have c is 15 plus 3. Sorry, this becomes 54. So the c at the end of the day is 15 plus 54. It becomes, our c is equal to 69. Okay, so that's the value of our c there. Let's have another example. So the next example, I've got d is partly constant and partly varies with. So we are given that information. We use this information to derive our simultaneous equation. Let's do that. So I'm gonna have 150 is equals to a plus 40h. The second one, I've got 92 and 54. I've got 192 is equals to a plus, so I've used a and h in this case, 54h. So I've formed two equations, equation 1 and equation 2. So with this one, it's simple. I can simply subtract equation 2 minus equation 1. Okay, I can simply do that. So I've got 192 minus 150 there. I will get 42. A minus a is 0. 54 minus 40, I get 14h. So my h becomes, if I divide there, I'll get my h is 3. Okay, so my h is equal to 3. Okay, fine. Now with this h, I can find the value of a. Let's find the value of a. I can use any equation. So I'm gonna use 150 is equals to a plus 40 by 3 there. So 150 is equals to a plus 120 there. So subtracting this side, I'll get my a is 30. Okay, so my a is becoming 30 in this case. So I can now write the equation connecting d and v as d is equals to 30 plus 3v. This is the relationship or the equation, the formula that is connecting d and v. Then we were asked to find d when we are given v. Okay, so let's do that. D when we are given v. Okay, d when we are given v. So our v is 73 and we want to find the value of d. Okay, so we simply substitute. We've got d is equal to 30 plus 3 by 73, like that. Okay, so when we have that, so the question is saying find d when we are given v is 73. So we will have 30, d is equals to 30 plus 73 times 3, we get 219. Okay, when we get 219, we can simply add plus 30 then, plus 30. So our d becomes 249. Okay, so that's the value of our d. We have answered the question, find d when we have that. Okay, so That's how you do partial variation. Otherwise, have a good day. Bye bye.